Yo. Okay. Welcome, guys. We made it to episode 4. I don't know how. I'm not complaining. Episode 4. Gotta try and do a decent amount of knowledge time. So today I sort of wanted to look at, oh my gosh, that's terrible. Still looks pattern, programming fundamentals. Also, that is not understandable, but that's fine. What else do I want to look at? And also, oh yeah. So we looked at last time some fundamental mathematical objects. I could probably explore them a bit more in the future if that would be cool. I just need to find out what kind of things viewers might be interested in. Get some viewer participation sometime. I can do that, hopefully. Also intro to calculus. Alright, so where do we begin? I guess we'll look at this first. So this is kind of talking. Essentially, I was going to do a thing on like various political stuff, philosophical stuff, and try and relate it to graphs, which we looked at last time. This is a graph. And how systems can be complex and how different views arise, and try and link like real-world concepts that are really like strong political views into maths. But I didn't really feel like it. I kind of just want to do technical math stuff. So hold this thought. Hopefully come back to you later. But for now, we're going to bench it and look at the other two. So intro to calculus. All right, I've only got 6 minutes. Let's go. Okay, what kind of maths have we done? We've done the 4 objects. So we've done how there's numbers, there's graphs, matrix numbers, and there are also, what else is there? Oh yeah, sets. Sets are cool. Sets are your best friend. You should learn about as much about them as you can. I want to do that. I might do a video just learning about set theory because it seems really useful. Okay, and of these things, the most familiar to people is numbers, especially if you limit to real numbers. Don't deal with all the complex number stuff. So you can branch from that. You can get variables. And essentially where x is where you have an amount but you don't know how much. I guess the really easy way with algebra, if I got any objects? If I got an object, that'd be cool. Hunt for objects. I got a Rubik's Cube somewhere. Oh, I do. Alright, so essentially the idea of algebra is I have an unknown amount in my hand, but you don't know how many. And essentially what algebra does is it tells you, it models a situation. So I have an unknown amount in my hand. If I had 1, 2 more, we still got an unknown amount, but we don't know how much. So we can model this as x plus 2. But then if we knew how many were at the end, so in here, got 4 objects. I don't know if we can see it on camera. Then what we can do is the whole idea of once we've got these fundamental objects we looked at before, with maths we can use these fundamental objects, manipulate through them, and create new truths from those truths. So this is truth number 1, but from this truth we can derive a second truth using algebra, that the amount I started with was 2, even though we didn't know that. So we've literally derived a new truth. We know that the amount plus 2 is 4. We also know the missing amount itself is x. Why did I look at this? Oh yeah, because we need to look at calculus. Alright, so what you can do is extend variables. This is the idea of variables. If you extend that just a bit more and have a second variable, you can have one variable depend on another. So it's pretty crazy to think about in terms of objects, but if you think about it in terms of time, it's reasonable to think that, and you can use a graph to sort of do stuff with 2 variables. If we've got time on one thing, so maybe that's time in minutes, we can put that here. Then what we can do is we can have an amount, maybe height. The height of a person might increase over time, something like that. So mapping between 2 variables, and we might have an equation for that. I can't think of a realistic one for that, but let's say the graph was instead like this, we'll call it n. Then we might have an equation, so maybe, oh, that's kind of boring, let's do something more interesting. So maybe n equals t squared plus 2 with a domain of t such that t is of the set 0 and greater. And you have your nice curve. And now we have an equation. And using that equation, we can move into the realm of calculus. The most common, we call these different variables. So we call this the dependent variable, and this the independent variable. Essentially, you move the independent variable, and then something happens with the dependent variable as you do it. The most common independent variable is x. So if we intro to calculus, if we use variable x, we can write some equations for calculus, but we're not going to really look at them. We're just going to put them out there, and then we can deal with that later. So the first equation is d of dx of ax to the n equals an x n minus 1. And the second one is that the integral from 0 to x of ax to the n dx equals a over n plus 1 multiplied by x to the n plus 1, and is not equal to minus 1. So we can look at what these mean another time if anyone's interested. But essentially I just want to put them out there right now really quickly in there, so we've done that. So programming to fundamentals of programming in computer science. How much time have I got on that? Like 60 seconds, let's go, that's enough time. Easy time. Oh. Yo. Go. Okay, let's go. Right. What is it? Oh, there's so much going on with the fundamentals of programming. So the key ideas we have are there's different types of programming languages. Sorry, programming paradigms. Essentially, paradigms are more important than languages. Essentially, once you've got the paradigm, you can put language on top. So for example, numbers are like paradigms, but language are like 4 or 5. So they're specific forms of the fundamental. So the same way in programming, we have different paradigms, they have languages on top of those paradigms, a different specific one. So the 5 main paradigms in programming, we've got assembly, commonly given symbol ASM. And then over here, we have, no, this is imperative. We have imperative on one side, and we have declarative on the other side. So imperative, we have procedural here. This is the most common paradigm that everyone sort of begins with programming, for good reason too, because it's most similar to these fundamental math objects, which mean people can get to grips with them a lot quicker than if we start with something else. Because in declarative, we have the functional paradigm here. Essentially, the functional paradigm, you immediately get thrown into lambda calculus functions, which are another object we haven't looked at. And you don't really look at them for a while, so hence why people really struggle to start with this language, just because the maths behind it is like rough to understand. Whereas this, even though it uses algorithms, people tend to be okay with algorithms. Even though algorithms does add to here, people seem to be okay with algorithms, so it doesn't take too long to teach. Right, I've got very little time left. So we've got heap, and we've got logic paradigm. I don't really know anything about logic, just know it exists. So these are the 5 main paradigms. There may be some other ones around, or some people may say some of these sit inside another, so therefore there's less, or maybe more. But that's the start. We can look at this later. It's a pretty fun topic. I had enough content. I was worried I'd run out of content before the 10-minute session, but it felt kind of nice, so I'll take that. Cheers guys, bye!